Hello, everyone, and welcome to our session where we will be sharing with you our experiences of a global learning collaboration that we've been involved with, where learners in Kenya, India, and the UK collected weather data and shared it with each other using Scratch. So, in this session, we will introduce to you the three organizations that took part in the project, explain how the project ran, share the outcomes for learners and the organizations, and then we will share the resources with you and allow you to have a go at some of the activities that the learners undertook. We'll finish off with next steps and questions. So I'll introduce myself first. As my title suggests, I'm Ben Davis. I'm part of the team at Barefoot, one of the three organizations involved in the project. A little bit about us. We offer free support to primary school teachers in the UK, so ages of learners 3 to 11 for our context. And this support helps the teachers to deliver computing lessons in their schools. How we do this? Well, this is through a range of activities, including online teacher CPD, by producing curricular aligned lesson plans and teaching resources, including resources for 3 to 5 year olds based on computational thinking approaches, and running live lessons where we have experts like myself, where we're zoomed into classrooms, multiple classrooms, and deliver content to the learners there. We use a lot of unplugged activities in the resources that we produce, with the idea of this helping learners to link computing concepts to their existing knowledge from other subjects and reduce their cognitive load. Last year, we saw us celebrate our 10th birthday. And on the slide on screen, you can see some of the data that we gathered together to communicate with people about that. One that we're particularly proud of, I'll just highlight, which is that we have, it's slightly higher now, but as of 10 years of practice, we'd reached into 83% of primary schools in the UK, meaning that 3.4 million pupils had benefited from the support that we had provided to their teachers. So now I'll pass you over to my colleague Neil, also from Barefoot, who will explain how the collaboration came about in the first place.
Okay, thank you, Ben. So as part of Barefoot's work with the Scratch Foundation, we're delighted that we were able to be part of the ecosystem leaders. And as part of that, we were out in Boston last year, where we met a number of partner organizations, and we were able to work with them on projects such as Build the Change, which was with the Lego Foundation, and also then discuss other ways that we might collaborate. And we're delighted that both Quest Alliance from India and the STEM Impact Centre Kenya were able to be part of that. So I'm now going to hand you over to Gangsha from Quest Alliance, who's going to tell you a little bit more about them.
Thank you, Neil. I'm Ghanshyam. I'm part of Quest Alliance, which is an India-based organization based out of Bangalore. Quest Alliance work with youth and learners, and largely we work on building 21st century skills. That also includes communication skills, collaborative skills, understanding problem solving skills, critical thinking. And how do we do it? We do it through teachers training and also designing some scalable solutions through Ideathon. We conduct Ideathon, hackathon with teachers. We train them. And we also believe that to bring a larger system change, we need to have a collaborative. So we also do a lot of networks and collaborative to engage with the system. For example, change in curriculum can be one example. And recently, as part of the ACC, Scratch Education Collaborative, Quest Alliance also anchored India chapter of it, which is known as Indian Equitable Learning Ecosystem Collaborative, that brought together 8 organizations. And we also worked on the idea of computational thinking with the marginalized learners. So this is all about Quest Alliance. Thank you.
No problem. And I will now pass to Margaret.
Okay. So thank you, Neil. My name is Margaret Kabucho, and I work with STEM Impact Center Kenya. So we are basically a non-profit organization, and we mostly work to provide creative spaces and resources for educators to interact with STEM. And how we do it is we run both in-school and after-school programs. And we have two tech centers, both in two cities, Nairobi and Eldoret, where we have established hubs. And then for the after-school programs, we either support schools in running their clubs, organize boot camps, and all that. And we also support teachers with teacher trainings so that they can make our program sustainable once we are out of their schools. Yeah, and we are also the ecosystem leaders here in Kenya and have been part of the uh, Weather Share program that we have been running in collaboration with Quest Alliance and Barefoot Computing. Yeah.
Brilliant, thank you. So, to tell you a little bit more about the Worldwide Weather Share, this was a global collaboration through our partnership with the Scratch Foundation, and it enabled young people to share weather data in their local area through Scratch, and it involved learners from the UK, Kenya, and India. And as part of this, we had a live lesson and a video call for learners to present their program. And I'm going to share one example of the kind of animation that children may have made or perhaps could make. So this was the example project we shared. So within there, we've got a range of programming concepts. We've got the various sprites, the characters on the screen or letters on the screen moving around, and also turning and going back to different positions. And those kind of primary programming concepts are often the ones that learners included in their programs, which I'll share shortly. So for the various organizations involved, there was a number of benefits. Firstly, it enabled us to have experience of working with both different groups of children, different groups of learners, and also educators, and for different groups to share their expertise, particularly with regards to pedagogical approaches, how we actually teach the subject of computing and the related aspects of programming. It enabled resources to be produced for different global audiences, and we also had support throughout from the Scratch Foundation. One of the ways we were able to share expertise was to deliver a live session for teachers in India in conjunction with Crest Alliance, which enabled us to go through the resources and also to share some of the approaches that are used in the lesson. For the learners, there were opportunities to use real-world data within their Scratch programs. This could be temperature data that they perhaps collected on a daily basis, and then put these into programs which enabled them to then share their knowledge and understanding of different programming concepts. They could collaborate with their peers and also share their programs and perhaps different things within the program, such as photos or sounds from the local area, and then learn from others about what's happening in different parts of the world. And Ganesham, you kindly shared these images here. Are you able just to tell us a little bit more about what they show, please?
Yeah, so these two images you can see here on the screen. One is that we did it in collaboration with Barefoot, where these are the fellows. In first of the picture you can see where Ben and Neil conducted their online live sessions to how we are implementing this worldwide weather data, and the session was further implemented by these fellows in their school ecosystem, where learners uh, 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 did that animations on the temperature that Ben showed some time back. So Neil showed some time back. Yeah. So these are the two reference of the picture. Yeah. Uh,
Brilliant, thank you. And as part of sharing the various programs, we created a Scratch studio where we enabled people to share what they have included and what they produced. And what we can then do is actually have a look at some of these programs. So the studio itself should be on the screen now. And we can see there's a number of different programs that have been uploaded. I'm going to share a few of those with you. So firstly, we've got one from a child who attended in the UK, and I'll share this one now. Share it once more. And then when I tap the different key each time, the background changes, and they've used the different letters on the keyboard to trigger different events. We've also got some really nice examples of different types of animation, and this one was completed by one of the children from Quest Alliance. Let's show once more. And then finally, the amount of time that people had to complete these programs varied. And for some children, it was a great opportunity to perhaps record further sounds and include things from their local area. And this is one related to Kenya. Okay, so some really nice projects there, and thank you to all the partner organisations for sharing those. So for the next slide, I'm going to pass you over to Ben to talk about working with the various educators.
Yeah, so what we're going to do is each of the organisations, we're just going to mention the support that we provided in our communities to enable learners to take part in these projects. So for us at Barefoot, some of the activities that we were involved with, we were recruiting schools to making sure that they knew what the project and what the project needed from them. So we were getting people who were signing up fully aware of the time commitment that they needed to put in, and we supported those schools in making sure that they had the technology to join the live lessons. We also developed the teacher resources that could be used to deliver this content, and provided support and advice to our partners organizations if and where it was needed. And finally, then the setting up of the Scratch programs and the Scratch Studio, so that we have the ability for learners to share their projects with each other. So I'll pass it over to Gansham.
Thank you, Ben. I think it was largely on the similar way that Ben described. So we collaborated with Barefoot, and we had the sessions from Ben and Neil with our fellows who are part of the collaborative. And they just had this sessions with the learner in school. on the principles of, or the idea or the framework that Ben shared on PRIM framework. They delivered it with the learners, and the learners made their projects on recording the date, the temperature of the from their region. So this is how the sessions conducted. Yeah.
And then Margaret, if you'd like to share.
Okay, thank you, Ben. Yeah, so for the program here in Kenya, we were able to recruit 3 schools who've been part of the program, and we have been working with them since May. And we did an info session to the partner schools together with their teachers, just to make them understand what the program entailed and how they will support their students. And then we also helped the learners in the collection of the data, and we give them some materials where they will record the data and ensure that they had the right resources to help them in the data collection. And then we also provided devices, especially computers, and ensuring that they have internet, especially during the 2 live sessions that we had, the demo session and the final weather share. So we just ensured that all students were well equipped and that they were able to join the sessions without any struggle. And then lastly was we did mentorship sessions to our teachers, both physically in person and virtual sessions, just to find out where they were, their progress, and how the students were faring on. Yeah.
All right, thank you, Margaret. So what we would now like to do is talk you through and walk you through even the resources that we developed, and discuss how we plan to use them. You might have picked up on Ganshan mentioning the PRIM approach that we used. I shall mention that and just go through, explain a little bit more what that means and why we used it. And then after that, there will be an opportunity for you to have a go at producing your own Scratch weather share program. So we used an approach called PRIM, and this is a popular programming pedagogy that we use. We believe it's very effective in an approach for supporting children when learning about computer science concepts and how to write code. There's a link on the screen, and hopefully it's in the chat, for a resource that was developed by Neil that is available free to download from Computing at School website, who are a sister organization of Barefoot. And within there, it's one of 5 approaches that's mentioned, and it talks you through and gives you an introduction to it. But we will give you an introduction here as well. So PRIM is an acronym, and it stands for Predict, Run, Investigate, Modify, and Make. What it does is it provides a sequence of learning that requires children, or gives them the opportunity to read and interact with code before they start writing it. And it allows us as educators to focus on specific concepts. So with the resources we developed, we were looking at repetition and initialization. And we can also focus on certain command blocks. And it's based on the use, modify, create approach, where the process of the ownership of the program is gradually transferred from the learners. So they start off using something that's been prepared by the educator, and they have to do different steps with it and end up with their own version. And on screen now, you can see just a little bit of a breakdown, giving you a few more steps as to what we do. So in the predict phase, we do just that. We ask children to make predictions about what a piece of code might do. Then the program is run so pupils can check their predictions. There's an investigate stage where you design activities that allow children to investigate the specific parts of the code or the programming blocks, the command blocks that they need to focus on. So this could be the one of the concept that you're looking at, or it could be new blocks, new command blocks that you are adding to them. It's very focused. You guide that investigation, so you're steering them towards getting the learning out they need. Then we move on to the modify approach, where this is more open-ended. where you ask the learners to make a few modifications to the program to get a specific output. So where in the investigate stage you're guiding them to do certain things, in this might be a change to the overall program where they have to apply their knowledge. And the process is rounded off by the make stage, where then you are giving learners an outcome that is very closely related to the program that you showed them in the predict stage, but giving them the independence to build that program themselves. Within all of these stages, we offer additional support to those learners that need it, and some aspects of it can be quite open-ended to enable you to stretch learners where that is needed too. So the brief that we gave to learners for the project was we wanted them to collect weather data during a specific time window. We wanted them to include this data within the Scratch program. So to start off with, we provided them with some examples of programs that we had created just to help them with generating ideas and coming up. So yeah, they knew the sort of the breadth of projects that they could use, because it was really, we were trying to make this accessible. We wanted to make it sort of a low barrier to entry, high ceiling, so they could go and they could explore and they could add things that they wanted to. But actually, as you saw with the projects, it could be simple, but it also had the opportunity for learners to take it as far as they wanted. So I think we're going to share one or two of the programs that we started off sharing with. So we used the one that you saw at the very beginning with the letters animating. We also used one that built upon the idea of conversation between the sprites, and that within that conversation the weather would be shared. So do you remember that, Neil? Thank you.
Okay, and got one other to
Yep.
share that we actually enabled the children to see as an example, and rather than the weather data related to temperature, this one had some light data.
So in this one as well, the photographs were taken at the point where the weather data was recorded, and those photographs have been used as backdrops.
Okay. So I think, Ben, you're going to go on now to talk
Slide
about how
24.
we collected the temperature data.
So we did suggest to from each organization, there was the suggestion that if schools were able to, they could use digital technology to record their data. So that could be a digital weather station that they had. It could be using a device like the microbit, but also again, we didn't want this to be something that prohibited people, children's or learners' involvement with this. So we also said, yes, analog methods are fine, and even down to the way of actually just using something like a weather app or going to a local weather station website and pulling the data off there. Similarly, we talked about how it might be recorded. Again, the example of using the microbit and actually logging all of the data within that and downloading that as a file. Traditional pencil, paper, pen method of recording it down, or using a Word document with a table, or using a spreadsheet to record it. But it was, again, open-ended, allowing each organization, each setting to do it in a way that worked for them. So let's go through the PRIM process that we did with the learners. So in the first step, we show learners the program and we ask them to predict what they think will happen. Now, we would usually give it to them as a sheet, with a sheet containing the program, and ask them to make annotations. Ask them to predict what they think will happen when the program is run. We encourage them to think about the individual command blocks, groups of blocks and the program as a whole. We also advise them or encourage them to make a note if something baffles them, if they don't know what a block or a certain set of blocks do, to actually write that down. Then we run the program, so it usually comes from the teacher program. So we're not expecting them to build the program and therefore possibly make a mistake. So we know that the program that we've got is the right one, and it's not a marking exercise. We run it, we let them have a look at the program, and then we let them realign their thinking. So now you've seen the program run, what do you think will happen? In the way that we had structured these resources, we repeated the predict and run cycle twice, and in the second set of code that we offered to the learners, the one that you can see on screen now, there were 2 additional command blocks that were added to these. And these are the second and third blocks that you can see in the program at the moment. And these are the ones that we introduced to get learners thinking about the idea of initialization. And by doing that, and a lot of the PRIM structure allows this to happen, we are allowing learners to discover things rather than telling them. So instead of saying, we've put these blocks in here for this to happen, why do you think these blocks have been put in here? Run the code. What was the impact of having those blocks? So they are discovering things as they go along. And this theme of learning through exploration is also explored in the investigate stage. And here we guide learners through making specific changes to the program to allow them to identify the key learning, the key concepts. So as you can see from the slide and some of the questions that we're asking learners to have a look at, we're focusing on the starting position of the sprite and what the values in those blocks mean. We also think about the value in the count loop and the impact that has on the program, and even down to thinking about the values in the weight blocks. Again, we're not telling them these things, we're pointing them towards things. Change the number. What happens when you run the program now? Can you see something different? So allowing them to find these things out through their exploration of the code. Right, I think it's over to you, Neil, for modify. Yep.
It is. And once the children have investigated the program, they then move on to the modify stage. And that means they actually get to change how the program functions by perhaps adding in different blocks or altering some of the values within the existing blocks. And you can see on the slide on the screen there that how to make the sprite turn, perhaps in a different direction or by a different number of degrees, are some of the tasks that the children might want to undertake to develop their understanding of the blocks. Once the program has been modified, again, children are now having more ownership of the code. They can actually go on to make their own program. And for this, we can allow children to have perhaps a program with different sprites in it already, or they can modify ones that they'd already produced. And it might actually be perhaps that they make one that is completely new. Often it depends on their confidence here as well. Now, for each of these stages, we might then go back and perhaps revisit some. We might also try slightly different pedagogical approaches. So here, the children are actually being asked to spot the difference between each code block, which means that they can see what the hide, wait, and show blocks do to enable the program to function slightly differently. So what we're going to do is ask you to now have a go at making your own temperature program. For this, we're going to give you around, looking at the time, I think shall we go for 10 or 15 minutes? What do we think?
Should we possibly do 10 and then we'd have time to share some
Yeah, that
from the
sounds
studio
good.
if people put them in?
Yeah, so within the chat, there should be a few links that you can use. There's a link to a starter project that has a single sprite moving around the screen. We've also got a link to a complete project, and I'm going to show you what the single sprite project looks like on my Scratch tab. So we can see here that we've got some code for the letter F, which I can run with the green flag, but none of the other sprites are actually functioning. So that's an option 2. And then when you're done, in around 10 minutes time, you can paste the web address of the program that you create into the Worldwide Web Share Studio, and there's an option there to add a URL. So you will need to share your Scratch program in order to do that. So just to reiterate, you've got around 10 minutes to create your own program sharing the weather data where you are. That might be the temperature, or it could be something else. And use the example programs if you want. And in around 10 minutes time, if you could try and post those to the Worldwide Web Share Studio, we'll then be able to share some of them on the screen. So we'll be quiet for around 10 minutes. Okay, welcome back, everybody. We've got some lovely programs being shared in the Scratch Studio. And I can see one here, which I will click on. So we've got some really nice example code here. What I'm going to do is just press C inside first, when I can see some interesting color effects as well. So let's have a look to see how the program functions. Oh, so we've got the word Manchester flashing and then the temperature spinning. Really nice. And I spotted another one in the studio as well there. And if we see inside this one, this person has had a go at getting their sprites all.
Is it cold or is it hot?
And there's a nice bit of sound there as well. I will just play it once more in case you missed the sample.
Is it cold or is it hot?
So it says, is it cold or is it hot? I really like the use of the sound recording there. Thank you for adding that. So some really nice examples, and I'm sure if you check back in time, there'll be some other bits added there. So we'll go back to the slides and start our wrap up. So the lesson resources that we've produced will be available soon from the Barefoot website. The studio can be found by searching for Barefoot Computing on Scratch, or we have the link that you've previously been provided with in the chat. And it'd be really good if you could consider how you might run a similar project in your area, or even with learners from different regions or perhaps different countries. Hopefully we've shown one way that it's been possible here today, and it might then be that this has meant you think, actually, we could do this in our setting, perhaps in a school or an after school club, or maybe with some of the learners you work with in a more informal way. So we've got some time for questions now. I can see that we've already got a couple in for us to consider, but I will keep an eye on our studio chat here as well to see if any further ones come in. So please do feel free to ask questions about what we've been talking about today. So one thing that we've been asked to consider is what is helpful for pupils when they're learning Scratch. So this one can be open to any of us on the video here. What is particularly helpful when pupils are learning Scratch? That might be a certain approach or resources or something to remember. What are people's thoughts on that? So what is helpful when pupils are learning Scratch was the question. Oh, I think, Ben, you might be muted.
Not sure what happened then. Right, yeah. I'm happy to start, and with that say, often it's keeping projects as simple as possible. I think I've been guilty myself of trying to expect too much of learners and try to make things look too fancy and too clever, and sometimes just being very simple with them and basic. You still get as much engagement with learners. They're still really proud of what they achieve at the end, but it then gives them the opportunity to personalize things. Whereas sometimes where I've given them a more complicated thing, it's been more about them just following step by step to complete exactly the same thing that I've done. I think what was really, really nice from the project that we did is the idea that it might look like this, and then the learners just pick there's some very, very different places, all of which fantastic. But that idea is that everybody is by keeping things simple, we allow learners to then express themselves and personalize them more. So that would be one of my tips, I think. There, happy
Nice.
to hear from anybody
And
else.
yeah, Gangshan, Margaret, or Alex, anything to add? The question was, what is helpful when pupils are learning with Scratch?
Neil, I can share my experience of working with this collaborative. One is I would certainly say what Ben said. It's about the relatability that learners are able to relate to the program or the projects that they create, writing their own stories. So in the digital medium. Second, also about the creativity because I still remember one of the learner and we did one Earth Day project with them, and we just the idea was that scratching diversity. Let's scratch something which relates to diversity, and one of the learner made dinosaur, and she said that the dinosaur is no longer here, but why not bring back dinosaur and just present it to the earth, I mean to the wider audience, to show that this was a part of earth sometime back, and maybe we should not do something which can endanger the species. So of course the way, the creativity, this spark in them. So I would say creativity and of course the relatability are the two main elements that learner likes to explore. Yeah.
That sounds great. We've had a flurry of questions in, which is great after that first one. So the next one that's come in is, can you share any feedback from educators about the support and guidance they received while participating in the program, or about their overall experience with the program? Looking at time, we perhaps got an opportunity for just a sentence or two from each organisation.
I think I've opened the chat from the first session that we did, which was the live lessons, and just from UK schools, it was the opportunity to actually use the internet in a way to collaborate with other schools, but using it in a way that actually makes use of the fact that they're using the internet, being able to do things and be in an environment where they would not be able to be, they wouldn't be able to have this collaborative experience where they were learning something at the same time as learners in India and learners in Kenya, and having that shared experience. So I know, and we have one school that's already asked, will we be doing something similar next year, and sort of asking, can they have one of the 5 places? So, and that's something that we wanted to get out of the project as well. That was one of the reasons why we were trying to keep it simple.
I can jump in for STEM impact, and one of the feedback we've received is, and especially working with new schools, new teachers who have not been exposed to Scratch earlier on. Majority of the teachers have been skipping coding, and especially because of the resources part. But when we step in with such activities and show them how it can be used in real life situations, the teachers are more motivated to learn more, and equally are the students. And having such a platform to engage learners and motivate learners in tinkering has really been one of the most interesting feedback that we get, that teachers are more interested in picking up what more can I do with this, can I teach something in biology, and that's what is picking up from other teachers and can be cascaded to other activities beyond the worldwide weather share.
Brilliant, thank you. And Gangshan, did you want to add anything at this stage before I go on to the other questions?
Just I have the similar answer also. Teachers see it as a pedagogical tool, potential pedagogies to introduce. Because, for example, I remember one teacher teaching the idea of rotation and revolution of the Earth. through Scratch. And yeah, so I was just trying to highlight that it has a lot of pedagogical, but I mean, it can work for other subjects as well, math, geography. Yeah.
That's great. Thank you. So time for a couple more. One, which is a quick one to answer, relates to how to share the projects to the studio. The link to the studio was in the room chat from before, but also will display the URL, the web address, in a minute. In order to add it to the studio, once you're signed into your Scratch account, if you share the program, that will then give you a web address that you can copy and paste into the studio. We've also had a question about how do we get students who get tied up in the art to move towards coding, or do you let them guide themselves? It's certainly a tricky one to address, and for this, in my sessions, I will typically give them a certain amount of a time to develop their sprites or their backgrounds, and that's something we often see in our resources as well. And often there's some really nice graphics skills to learn in there as well, perhaps how to use the fill tool, how to zoom in, and these are all explicit skills that we can perhaps teach as part of that. It might then also be that for certain learners, they perhaps need guidance on where to go next. So structuring it into the lesson carefully, I think, is a really nice approach. So there's been a few more questions that have come in. Unfortunately, we haven't got time for all of those. So I'm going to share our final bits here. The websites for the various organisations are on the screen, and the primary pedagogy guide again has been shared in the chat, but the link is there, and the lesson resources will be on the Barefoot site soon. And do please share your programs from the worldwide Weather Share that you have produced as well, and the content from within these slides that relates to the lessons will also be on the Barefoot side as part of those lesson resources. There are a few more programs in the Scratch Studio as well, so thank you if you've had a chance to upload those, and do have a look yourselves. There's some really nice examples there. So thank you from me. I'll just let everybody else say goodbye if they would like.
Yes, thank you for joining us and allowing us to have the opportunity to share the wonderful work that the learners did across this collaborative project. So, thank you.
Okay.